All right, let's talk about C programming interviews. If you've ever felt that little bit of dread right before one, you're in the right place. Today, we are going to crack the code on the most common questions and give you a solid blueprint for success. Let's dive in.
So, let's just ask the question right out of the gate. Why is C, a language that's been with us for literally decades, still so intimidating in an interview setting? Well, it turns out there's one single topic that consistently trips people up, and it's what separates a good candidate from a great one.
Yep, it all comes down to one word: memory. You see, in C, you are in complete control of memory, and that is both its greatest strength and its most significant danger. Interviewers know this. They know that if you can prove you understand how memory works, you've proven you really understand C.
To really get a handle on memory, you have to start at the very beginning. That's why interviewers love to kick things off by asking about the compilation process. I mean, think about it. If you don't know how a program is even built, how can you possibly manage its memory effectively?
It's really a four-step journey from your source code to something you can actually run. First, the preprocessor zips through handling things like comments and macros. Next, the compiler takes your C code and turns it into assembly language. From there, the assembler converts that into machine code, the ones and zeros. And finally, the linker pulls everything together, your code plus any libraries you're using, into one single executable file.
So when you run that file, it gets loaded into memory in a very specific layout. The text segment, that's just your code. The data and BSS segments are for your global and static variables. And then you have the two dynamic parts, the heap, which is where you manually ask for memory with functions like malloc, and the stack, which automatically handles all your function calls. Knowing this map is absolutely fundamental.
And that brings us to the main event, navigating the memory maze. Because you are personally responsible for managing everything on the heap, you can bet that interviewers are going to grill you on all the ways that can go horribly wrong.
The most famous problem, of course, is a memory leak. The best way to think about it is like booking a hotel room, but then forgetting to ever check out. That room stays marked as unavailable, and if you just keep doing that over and over, the hotel eventually runs out of rooms. Same thing in C. Your program slowly eats up all the available memory until it crashes. It's a silent killer.
Now, what's even more dangerous, and frankly, a bit more interesting, is a dangling pointer. This is like checking out of your hotel room, but you get to keep the key. If you try to use that key later on, who knows what you'll find? You might walk in on a new guest, or maybe the room is just empty. You have no idea. We call this undefined behavior, and it is an absolute nightmare to debug. So you should fully expect to be shown code and asked to spot memory leaks or find dangling pointers. They'll definitely ask about segmentation faults. That's your program trying to touch memory it's not supposed to. And they'll want to know if you can use tools like GDB, the GNU debugger, to actually hunt down these kinds of bugs.
Okay, so if memory management is the big challenge, what's the solution? How do we master it? Well, the answer is pointers. I know they have a reputation for being tricky, but they are the essential tool for taking control of memory in C.
At its core, a pointer is actually incredibly simple. It's just a variable, but instead of holding a value like the number 5, it holds the memory address of where that 5 is being stored. That's it. And that one simple idea gives you an unbelievable amount of power.
So why the obsession in interviews, right? What is it about manipulating these simple addresses that's so fundamental to writing good C code?
Well, it's because pointers unlock pretty much everything else. You literally can't allocate memory on the heap without them. You can't pass big data structures around efficiently without them. You certainly can't build things like linked lists or trees. And you can't get into more advanced, flexible code using function pointers. They are the bedrock of serious C programming.
Speaking of data structures, here's a classic interview question. What's the difference between a struct and a union? With a struct, the compiler allocates memory for every single member inside it. But with a union, all the members share the exact same memory space, which is just big enough to hold the largest member. It's a really clever way to test if you're thinking about memory efficiency.
And to take that idea one step further, we have structure padding versus packing. See, by default, the compiler actually adds little empty bytes, padding, inside your structs. It does this to align the data in a way that the CPU can access it faster. But sometimes, especially in embedded systems, you might want to pack the structure, which removes all that empty space. You save memory, but you might take a small performance hit. Understanding that trade-off shows a really deep level of expertise. Okay, let's shift gears a bit. It's not just about memory structures. Interviewers also use very specific keywords to gauge just how deep your knowledge goes. These are the little details that really separate a pro from a novice.
A perfect example is the difference between static and global variables. Now, what's so interesting here is that they both have the exact same lifetime. They exist for the entire time the program is running. The key difference, the part they're testing you on, is the scope. A global variable is public. You can get to it from anywhere. A static variable, though, is private to just the file or function where you declared it.
You'll also see questions about this whole family of specifiers. For example, volatile is super important in embedded systems. It warns the compiler, hey, this variable might be changed by hardware, so don't try to be clever and optimize it away. Const is all about safety, making a value read-only. And inline is a hint for performance, asking the compiler to maybe skip the overhead of a function call.
Here's another fundamental concept: declaration versus definition. The declaration is the what. It's a promise you make to the compiler, saying, hey, a function with this name, this return type, and these parameters exists somewhere. The definition is the how. It's the actual code inside the curly braces that fulfills that promise. Getting this straight is key to making sure your code links correctly.
Okay, so we've covered the building blocks, the memory pitfalls, and all those little language details. Now, for the final part of an interview, it's time to put it all together. It's time to actually solve a problem.
And you are almost guaranteed to see this absolute classic: reverse a singly linked list. This problem isn't about some obscure, clever algorithm. No, it is a pure, direct test of your ability to manipulate pointers, especially when you're under pressure.
Now, what interviewers care about most here isn't that you type out perfect syntax on the first try. It's your logic. They want you to talk them through the solution. The classic way to do it requires 3 pointers. Let's call them previous, current, and next. You just walk through the list, and at each node, you reverse its link to point backwards to previous. Then, you just shuffle all 3 pointers one step forward. It's like this elegant little dance.
And of course, you'll see other kinds of low-level tests too. Bit manipulation questions, check if you can work right down at the hardware level. Recursive string problems are a great test of your understanding of the call stack. And synchronization questions, using things like mutexes to stop race conditions, test if you can handle concurrency. All of them are designed to see how well you can think at a low level. So look, here's the most important takeaway. A C interview is not a trivia quiz. It's an evaluation of your mental model. They don't just want to know if you've memorized function names. They want to know if you can actually see the memory layout in your head, if you can trace pointers through a data structure, if you can reason about performance from the silicon up. The ultimate question they're asking isn't just, do you know C? It's, how do you think in C?